Thank you very much, Gary. You got a sense of how interdisciplinary we are, where Mr. Matthews is able to give a biology talk, and I wish I could do just as well talking about our infrastructure, but I'm not quite as talented as the previous speaker. My part for today is to talk about transportation fuels and the role that UC San Diego is going to play in being part of the solution to the challenge of transportation fuels. And as you can see from this slide, globally about 15% of the anthropogenic or man-made greenhouse gases, these are the gases that relate, of course, to CO2 production that you saw from Vice Chancellor Haymuth. About 15% of those global warming gases globally come from our transportation fuels. But you can see where this is headed worldwide, because if we look in California, of course, the figure is much higher because of the much higher car use. And so the message here, of course, is that we need to find ways in which we're going to replace this impact on global warming from the use of transportation fuels by using biofuels. And biofuels are transportation fuels that are derived from either what you grow or what you throw. Okay, so these are fuels that come from either crop plants or a wide variety of wood or municipal waste. We use currently in the United States about 140 billion gallons per year of petroleum. And Congress recently, in 2007, passed as part of the Energy Security Act, a renewable fuel standard that said basically by 2022, we're going to need to be producing 36 billion gallons per year of our transportation fuel mandated by Congress to be renewable or biofuels. And interestingly, Congress has been far-sighted enough in this instance to mandate that 2/3 of that needs to be advanced biofuels. Why? Because it's become very clear that the current production of ethanol using the starch that's present in corn is not a sustainable solution for the production of biofuels that will have an impact on greenhouse gas emissions. The reason is, of course, is that corn requires a huge amount of fertilizer, a great deal of water. So when you do your energy equations, what you really find is that you're actually putting more petroleum in to produce that gallon of ethanol from your ears of corn. And of course, there are lots of issues related to land use and removal of forests and virgin prairie grasses to grow crops like corn. So we have solutions, and those solutions are being worked on here at UC San Diego across a broad swath of units. So our marine scientists are coming together with our biologists, our physical scientists, our engineers, to look at two key solutions, one called lignocellulosic, and we're going to test you on spelling that shortly afterwards. Lignocellulosic ethanol is the ethanol that's made from the leaves of plants rather than the ears of corn, and is a far more efficient way of producing ethanol, as well as algae. And so what we're going to see here at UC San Diego and with our partners in the community here on the Mesa, there's a great deal of interest in the business community on our renewable fuels efforts, is our researchers are working on new types of energy crops that are far more efficient than corn. Over here you see a little baby of one of those energy crops called miscanthus. You can see in our greenhouse here at UC San Diego, these guys grow to about 13 feet tall and produce about 3 to 4 times the amount of biomass than corn does per acre, with about 1/10 of the water and fertilizer. So there is a possibility that what we'll see in the next 5 to 10 years is much more efficient energy crops produced that will be grown on degraded land, that will be less competition for food. However, there is still a big challenge for these energy crops because of water availability. So I believe that the bleeding edge is really around the use of algae, otherwise known as pond scum. And here is a flask of algae that is actually producing biofuel or biodiesel as I speak. So if we were to dry down this flask and give it a squeeze and pop it into the tank of one of Melanie's buses that we're going to hear about in a minute, she'd be able to drive about 100 feet down the road. This type of biofuel production is going to be a dramatic change in the way that we can impact greenhouse gas emissions from transportation fuels, because this algae growing here right now, producing biodiesel in this flask, is growing in salt water. And so what it's going to enable us is, together with people at SIO who really understand the ecology of these algae and identifying new algae species, together with business partners from the community, our biologists, our physical scientists, we're going to be able to identify algae that can be grown in large-scale farms on land that is absolutely not used at all for crops. And in this way, you're going to provide a sustainable solution for the production of biofuels. So, of course, the message from the Dean of Biology is this, which is that biologists can save the world. And the way we can save the world, of course, is through our mission of research, education, capturing the brilliance of our students, and through public outreach. And in talking about the brilliance of our students, I'm very happy to introduce Melanie Zauser, who is a graduate student in UC San Diego's Mechanical Engineering Department, and she's going to tell you about our new Green Line bus, which is going to be fueled by biofuels beginning this summer. Melanie.